View management. The day before we just invent the similar to SolidWorks view management about direct input, actually including mouse and keyboard. To zoom in, zoom out, and rotating the 3D model on the screen. Right, we'll copy all the program from CMS CAPP to RPG2. First, we have to open Visual C++ 6.0 and workspace RPG2. Open RPG2.dsw to see if still the original program to show the floor as well as 15th Uden running in animation. It is correct. Then we open the CMS CAPP's program at the left half screen. The file open workspace from D drive CMS GAC CAPP CH CMS and open the DSW. We started from copy the program from frame and started from show view. View key. Okay, the whole program of view management started from here. This first. And copy. Copy to the Winman of RPG2. for the program before begin scene. Suppose here. And then continue the copy. Remove this first. Okay, delete. And the previous started from here. This line is this line. So started from here and then continue and continue up to here. Copy. And paste here. Here is a jump. We'll mark the index to here. Then give one space. Oh, now including this. Okay, before debugging, we remove one routine first. As zone in, zone out, we have to specify a 3D points by means of a routine length get object 8. We leave debugging get object 8 at the second step. Before we doing anything, we have to see the camera move will duplicate with others. So the camera move, we add A at the real. And press Ctrl F2 to mark this first. And then not the X move, Z move. Still including S move A and Z move A. And F2, go back to these positions. So the mouse in middle button pressed, continue pressing. Okay, the exports for cameras in here. You can see we use exports plus 0. The exports with arrays is for the position of the Udon. So continue writing the program. The S-pos for the camera, we have to add a 0. Z-pos with a 0 at real. In here, we don't want to talk too much about this period of program, because at the previous lectures we already discussed and talking very clear. In here we just doing the procedure to move the view management program into RPG2. Later on, the user can adopt this period of programs to write their own programs. So we change all the Y-pos, Z-pos to add a 0 and a real. Okay, in here we leave this one still Z move. The S move, the Z move, we leave to the animation use. So continue to this light, the camera. So this one is for zoom in. Still S move, no A at real. And this for camera, we have to add a 0 at real. Y pos with 0, Z pos with 0. And the keyboard, S move. You see, if we add A and real, plenty of S move and the Z move has to do the adding procedure until the view key equal to Z1, the S pos with 0 plus S move, the Z pos with 0 in adding the Z move, the S pos camera move with 0, the Y pos with 0, the M pos with 0. That's it. But this one, the height of cameras copy, we have to add a real of this variable. Okay, let's compile to see if still any problem or not. Then Control F, searching error. The first one is S elapsed missing, and then Control Home to the top of the CMS CAPP and the search SE LAP. Okay, found it. We copy this these variables and to the top of RPG and find the space and real of previous variable and pass the S elapse and Control F2 mark the position. Later on we just pressed the function key F2 will jump fast back to this place and then save all, rebuild all. Now the arrow 34 to find next arrow. The M keyboard. The M keyboard you can see in here the Winman of CMS CAPP. The M keyboard is this. Use this input device class open M keyboard. Then we have to copy this one to insert to the same position of winman.h of RPG2. Okay, then we save all and rebuild all. So 15 errors only. X mouse. Okay, go back to the Winman of CMS CAPP and Control Home and search the XMS. Okay, it's long. Copy the whole lines to RPG2 in this position. Past. Then save all, rebuild all, execute the program. So 13 left, Control F, arrow. Keyword X MS, still MS. Control Home. Keywords in front, just this one. Copy to here, F2. Simply press the right button and paste. Rebuild all. So 7 arrows. Control F. Press Enter. Keyword 2. Keyword 2. Control Home. Keyword 2. This one. Copy. F2 to the variable position and paste. Save all and rebuild all. 7, then 5. 5 arrow only. VECDIR. Control Home. VECDIR. Oh, this one. Copy. Put down here. 5 arrows. And how much this time? 1 only. Okay. Finding the only 1 arrow. View key. View key in here. The variable is putting integer in the frame position. So we copy the view key and the frame here. Go to the top of the frame in integer. Where is integer? Okay, integer similar to long, we just put here if a positive integer. Okay, Y key. So compiler, 0 error. Good. But don't forget the original viewport. How to get the original viewport? At the initial, we have to set the initial viewport. The program stated in here, the camera X position minus 300, Y pos 0, Z pos minus 4500, and the C Y pos 1100. SRC, YRC, ZRC equivalent to 0, and the code camera move and the camera set camera. So copy this one and put into initial. Where to put this period of program? How about at the before the end, return truth? Okay, so initial camera position, but don't forget the camera position has to add a 0 after at the rear of S pos and the Y pos as well, and the Z pos the same, and move the argument first with S pos with 0, the Y pos with 0, and Z pos with 0, and compiling 0. Okay. Then we go back to open the marked routine get object at. We'll see in here in header file of winman get object. It's a bool get object at the private of CAPP. So the same will add this one at the winman CAPP in private. How about to put at the last one, and then the solving routines of get object at we copy it from here. Get object. The original program is from Jing Eden. It's a very complicated 3D calculation, and from this line CAD mode we're adding some picking and removing functions. So this period of program is written by me. Okay, copy and put back to the winman before frame. Pass and then debug. Before doing anything, we can see the object name known object, while in our program we are character object, so whole known object has to be changed. back to character object. We copy it and go back to here. We simply search the room. So this one put pass in our system RPG2 object without S and only one dimension array. We don't need to bother about 9 station, only 1 station, and search for next room and put the cursor here and pass and remove S and the first dimension line and search the next one, put the cursor and the past and S removed. And next one, past. And continue. So this is a variable without dimension as well. We add m rooms later after we solve first the searching room first. Past is remove, the dimension remove. Past and then past. And then continue. Okay, no room at all, only this one. Let's see the m rooms in the header wingman of CMS CAPP searching room. Okay, along with 10 station, but here we only one without station. That's it. Okay, then save. Seven arrow only. Control F. Or hit save. The first arrow. This variable, not C. Go to the top, Control Home. HIT save. Just copy. And we better Control F2, mark here. Right now press F2 to the top, to the variable area, and past the hit save, and then rebuild all to find another bug, 6 only. So distance 1 save. Control Home. Distance 1 and save. This one. Copy and pass. Five arrow only. Control F. Shady mode. Then Control Home. Shady mode. Copy. F2. F2 to the variable area and pass. Rebuild all. 4 errors. Control F. Error. IM. Oh, it's 4, so it's an integer. F2. So integer. Okay, we open a new integer, and the variable name is IM. Rebuild all. 3 errors. Control F. Number things. Number thing 1. Number thing 1 here. Okay, copy to here. F2. And save all. Rebuild all. 1 error. Control F. And IS save. ISF IM. So we put this variable in the same position at the real of IM. And save all and rebuild all. Okay, 0 error. That's wrong. To see the adding the function of the newest program to do view management by mouse and keyboard. Go. We'll see the flowers and 15 students learning in dynamics. Oh, it's learning, but still the original one, because the animation running, we still use the camera position. So we use the whole we just remove the camera position of the animation settings. Okay, how to do it? F2. Go to the frame and find the position of show animation, and then remove the first chunk, construct, and save camera program, and then the instructions of camera point, all the camera's functions removed, so the set animation keep there. We give the constant speed, suppose 1. Then we don't have to use get times to remove these lines, and remove the mouse acquire and the mouse read, and we differentiate S move from 1 to 2. 1 to 2 is 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 1 to 2 the main camera's program. We use the A here. We define A already. X move A, Z move A. We try to use, but we think it's better to use another name, S move A, Z move A, and a specified show animations program. So here we add A here. The speed specified 1 only, and 15 Udens. Expose has its own. Every Uden has its own positions. So here we have to add A and a real. And if any moving, S move A or Z move A has any variation, then we have to set animation and have to move the Uden to the new position for each Uden. Okay, the camera instructions already moved, and continue to do the whole animation management program by mouse and the keyboard. That's it. So let's save to see the difference from last show. In here we can see the floor from the position defined at the initial program, and 50 Udens running. Terrible. The floor with the same speed moving forward the same direction, the same speed as the Udens. Okay, this is a terrible problem. The floor should exist statically at its original positions. The Uden running is okay. Okay, let's find the reason why the floor moving as well. Let's go back to the program to find the show floor. Can lead us to find the floors rendering or whatever. So this one, there are ground HV line HVB create and the dot set and then render. The problem is the creation of the floor with vertex buffer. So we use GRND to search. Okay, in here, in the initial position routine, before creation, there are initial the 15 Udens in animation. As I know, the last one, the 15th objects with animation, will leaving the influence to the vertex buffer. The vertex buffer will inherit all the dynamic matrix and doing the running the same as the last Uden, and the speed as well. So how can we solve this problem? We find a solution is to create an additional static Udon by means of org.x created by SolidWorks, which is a white dot at the original position of Cartesian coordinates as 0 until 15 finished at this position. As program running to here, the I is 15. Then we can create the 15th object without animation. How to do it? We only have one mesh, so this time we change the Vman. The mesh will still give a rate to the maxima 256 and the character objects 256 as well, and the animation 256, and the Udon's positions 256, the Y 256, the Z positions 256. That's it. So in this case, the character mesh with array. Then we go back to the program. The character mesh with arrays. For the animation, we use the first one, 0. In the animation, is one mesh, 15 objects, 1 to 15. So in this case, how to generate the org.x objects? We have to use character mesh load first. The object, the index is I this moment is 15. If the for loop finished is 15. And the X file named org.x. You can find org.x at RPG2 at the RPG demos file folder inside the data file folder. You can see org.x already prepared. The static objects after mesh load, we have to manage object create. You don't need to do animation load or set loop because it is a static object. So character object I create with the mesh, the index should be I instead of 0. And after this static object create, I has to add 1. Totally 16. Then we have to alter the show animations from 15 to 16. So at here, set animations, don't bother, just the 15. But at the display, the next one, begin scene, end scene, at here. Not only the 15th Udons in animation, we still have to render one more, is the dot. After the for loop, the I is 15. The 15th render. And then we change the position of the floor at the rear of the Uden, and the dot of the original position of Cartesian. Okay, save all and rebuild all. One error. Let's see what is the error. Okay, the free in the shutdown position. Okay, how about we give the array I and move into the for loop. Okay, rebuild all. Zero error. So let's go. Say debug, go. You can see the difference of the floor. In the original settings, like this, the 15th Uden's running 90 degrees, heading to the right, but the floor still stayed there, and you can use the new function of view management, the keyboard. The mouse okay, but the keyboard still not using. Okay, let's find this bug. What's the reason the keyboard cannot work? The keyboard, the initial and then the usage. The usage is at the frame position. Let's see what's difference from CMS CAPP. In here, the keyboard acquire and the read. And how about the CMS CAPP writing? Okay, we just copy, so no problem about this. But it seems the keyboard are not initial. The keyboard initial should be inside the routine of initial. Initial is here. Let's see. This is view. This is initial input and the mouse. And then let's go back to CMS CAPP initial to see what's the difference. This is the graphic screen. Okay, here. M input initial. Mouse create. The keyboard has to create. Copy. Done. down here and press. So with the initial of the keyboard, then the keyboard hopefully can work. Let's see. Compiler and 0 error and go. Okay, the mouse. Okay, just simply press the D key, the A key, the W key, the S key, the Z key, the X key, so the keyboard can work as well. And how about the animation? No animation, so the Udon not disappear, not appear, and then no flower. Then the flower only. Then with animation. Okay, it seems perfect. Ending.